Hi everybody, my name's Ortinsky and welcome to Let's Play Math. So this is a video response to a Let's Play that a user named MrKizah is doing. And the game that he's playing is called The Witch's House, and in it is a puzzle that caused him some frustration because it involves a fair bit of math, all of which he did in his head. So, and the math is non-trivial, so I'm going to write it. So I have the solution written out here, and so if you just want this, if you know what I'm talking about and just want a solution to the door and get out, then there it is. Just pause the video, copy it down, and we're done. I'm going to erase it and go through the puzzle and the math that I did to easily solve it without any stress. Okay, so our premise is you have a locked door, and on the door is a puzzle. The puzzle being the words top left, top right, bottom left, bottom right. And right after that, it'll be 4 digits. And if you go to the corners of the room, each corner has an algebra phrase in it. So the solution to the puzzle then is to solve the algebra, and that will give you the 4-digit code that will open the door. So what I'm going to do is go through the math step by step and how I found the solution, and it is the correct solution as Kizah proved in his video. So here we go. Each corner has its own phrase in it, which corresponds to one of the digits. So the top left is the number represented by the top left corner is equal to the bottom right corner plus the top right corner. The top right number is equal to the bottom left number times 666. The bottom left number is equal to the bottom right number minus the top left number. And the bottom right number is equal to 6. So what we have here is a solution space that has 3 independent variables or 3 dependent variables and 1 independent variable. The 1 independent variable is the bottom right number, and that's the number we're going to use to solve everything because we know what it is and it's not going to change. So then we have to find a solution for these three using only this number. And the way we get that solution is by making substitutions beyond using the various phrases we have here. Because each of these phrases is correct in the solution space. The problem being is that we don't have precise answers for everything, we only have vague answers. But I'm going to show you how the substitutions work and how I got the answer. So I chose to start with the top left number. It was an arbitrary decision, but I suspected it would be slightly easier to solve. So first I put all the variables that we know into the line. So the bottom right number is equal to 6 plus the top right number, which we don't know. And now I substitute what we know about the top right number into this line here. So we know that the top right number is equal to the bottom left number times 666. And I'm going to keep doing substitutions like this until we only have 1 variable left in the line, because once we do that we have a solution. So the top left number is then equal to 6 plus the bottom left number. The bottom left number is equal to the bottom right number minus the top left number times 666. And we know what the bottom right number is. The bottom right number is 6. So now we only have 1 variable in the line, which means that once we get that 1 variable to one side, then the other side of the equation will be the answer to this digit. So let me carry this math through. We have to carry 666 into both these phrases because the bottom left number is only one number. We can't split up these 2 phrases. The math will be wrong. So 666 times 6 is 9,306 minus 666 times the top right number. No, top left number. Yeah, because we have the answer. So then if we add 666 top left to each side, then these 2 phrases cancel out. And the left side is equal to 667 times the top left number. Which means that this is equal to 396, which is equal to 4002. And then we divide both sides by 667 so that we have TL all by itself, which means that this TL is equal to 4002 divided by 667, the answer of which is 6. So now we have a solution to another dependent variable, and we can use that to make substitutions into the other ones, to the other phrases here to get the answer. The bottom left number is equal to the bottom right number minus the top left number. The bottom right number is equal to 6 minus the top left number, which is 6, which is equal to 0. So if the bottom left number is 6, then the top right number, which is the bottom left number times 666, that's just equal to 0. Which means that our solution here is 6006. Which you'll find is the answer Kaiser came to in his playthrough. And that's how you solve the math of the witch's house.